Hi everybody, good evening. Welcome to this lesson 2 of technology. Today we are doing hydraulics, continuing from Pascal's law. I'd like you to do yourselves a favor and quickly jot across to the PowerPoint presentation which I gave you. Right, so we are doing hydraulics. The hydraulic press and the hydraulic jack comes from the word hydroulos, meaning water pipe. Notice that all hydraulic systems use hydraulic fluids like oils, brake fluids. Here we see a 600,000 ton press using the hydraulic system, incredibly strong. They're used to crush cars, compact objects, and press. Now what I'd like you to do is look at this hydraulic press system. We have a cylinder and a piston. The hydraulic power is converted to mechanical power. The system and piston is called a ram. We have a pump. And we have pressure which is transmitted. I'd like you to write down the meanings of those two words from each block. Then we have a process. And in this process, the input experiences a larger output due to the pressure applied in this hydraulic system. I'd like you to jot down this flow chart and fill in the words as the process flows. Here we have Pascal's principle. If you fill up a balloon with water, a round balloon, and prick it all the way around, you'll notice that the water flows to an equal distance because the pressure is equal on every part of every surface of that balloon. You need to learn Pascal's principle, which states that pressure exerted on one part of a hydraulic system will be transferred equally without any loss in all directions to all other parts of the system. Learn it word for word, please. An alternative to this is quite accurate, which says that the pressure is undiminished with equal force on equal areas and at 90 degrees to the container wall. In a balanced system on the left, the pressure coming in, the force coming in is equal to the force going out because our area is the same. Now, if this was a closed system, then the pressure would be equal throughout. So therefore, if we're trying to work out what the forces are on each side, we don't need to take the pressure into account because the pressure is equal on both sides. So we can work it out by saying force over area must be equal to force over area. Over here we can see the force coming out will be double. Why? Because the area is double. Now we come to our calculations. I want you to please notice that in your textbook diagram, this is not a camshaft. This is showing you the radius of this piston. The radius of this piston is 10 centimeters. The radius of this piston is 40 centimeters. So how do we work out the area of a circle? Well, the area of a circle is pi r squared. It's pi, which is a constant, 3.14. And we times it by the radius squared. So, if I want to find out what the force is of this cylinder, I need to work out its area. So the area of cylinder A is pi r squared. Now what is pi? Fortunately for us, we don't have to take pi to its 3.141592653589997 etc. to infinity. We just simplified pi is equal to 3.14. So pi r squared, it's 3.14 times 10 squared centimeters. Not 10 squared centimeters, 10 centimeters squared. And the area of cylinder B is pi r squared, which means it's 3.14 times the radius is 40 square centimeter. This is not correct. So, how do we work out mechanical advantage? Always output over input. Why? Because we want to have a greater number here to have an advantage. It's no point me pumping 15 watts into a system and I get 10 watts out. There's no mechanical advantage. So our output must be greater. So the area of cylinder A is 314. The area of cylinder B is 5024. When I divide them together, I get a mechanical advantage of 16. So what we must remember? We must remember the formula. Mechanical advantage is output force divided by input force. It could be the output area. It could be the output distance. But it's always output divided by input. The other formula we need to remember, which you know already, is the area of a circle, because the pressure is applied by the whole area of the cylinder. The whole area of the cylinder. So that's why we've got to realize that. So we only have to know mechanical advantage is output over input. Now we know that force equals pressure times area. So we've got that formula over there. And so we get the mechanical advantage of 16. Now I would like to move to enabling task number 1. Right. Number 1, we have a press which exerts 200 newtons and it results in an output of 800 newtons. Now they want to know, what is our mechanical advantage? Well, please keep these two in mind. Our mechanical advantage is our output over input. So from that, we can get that our output is our MA times our input, which we'll come to later. So mechanical advantage equals output over input. Always write down your formulas so that you don't get lost. Right. Which equals, what is the output force? 800 newtons. 800 newtons. What is our input force? 200 newtons. 2 goes into 2 once, goes into there 4 times. 4 times. That is your answer. Your mechanical advantage is 4 times. That will be written 1 is to 4. For every newton of work I do, I produce 4 newtons as an output. Now that's pretty awesome. Now we come across here to something that's a little bit more difficult. We have 2 cylinders, an input and an output. Now I can see already that the output cylinder is larger, 3 times larger than the input system. So we're going to have a nice mechanical advantage there. Now they want to know what the mechanical advantage is. So we write down mechanical advantage equals question mark. So let's go to our radius. This radius is 0.5 millimeters. That means in the cylinder, it's going down that way. The radius from there to the edge is 0.5 millimeters. Right. Now, this cylinder is 3 times greater. It's 3 times bigger. It has 3 times more area. Now, the way we work it out is that means that it must have a radius which is 1 to 3 times longer. Right. So the radius is 3 times 0.5 is 1.5 millimeters. Now you think 0.5 versus 1.5, not much difference. But notice that the longer the radius, the bigger my circle. And it's quite related. In case you're interested, I was looking it up the other day. Pi is the relationship between a circle and its diameter. Basically, once round the circle is 3.14 diameters. So pi is a ratio, almost like working out the circumference of a circle in relation to the radius. So in order to work out area, we go back to our formula. Area equals pi r squared. Area equals pi r squared. Pi is always 3.14 times 0.5 squared. You don't square the centimeters. They become little blocks, which equals 3.14 times 1,5 millimeters squared. Okay. So let's work out what the area is of each of these. So 3.14 times 0.25 square centimeters equals 0.785 millimeters squared. That equals 7.065 millimeters squared. Now, how do I find my mechanical advantage? Output area over input area. 7.065 divided by 0.785 equals 9. My mechanical advantage is 9 times. Always underline your answer. Now, with this little sum, I have a lift, which is pulling a weight of 350 newtons. So it's pulling up 350 newtons. MA equals 5. So that there will be force. Su, or your output. And this is your input. So they want to know, what is your input? Now please, MA equals output over input. But if you want to know what your input equals, use the triangle. And the triangle is always you want your output will be your advantage you got times your input, correct? There's your triangle of technology, because what you want is your advantage times what you put in, correct? So now they want to know, what is my input? Well, your input must surely be your output divided by your MA. So what is your output? So let's write the formula down so it's clear. Your input equals your out divided by your MA, right? So your output is 350 newtons divided by your advantage. 5 goes into there 70 times. Your advantage is 70. Wow. That's really, really cool, I must say. This is an interesting one I want you to see. You push down 60 newtons of force onto your deodorant, but you only get 15 newtons of an output. So let's work out what's going on here. They want to know what your mechanical advantage is. Well, I know my mechanical advantage is equal to my output divided by my input. We should know that by now, hey? So my output was 15 and my input was 60, which means that it's a quarter, 0.25. It is less than 1, which means we do not have a mechanical advantage. If your mechanical advantage is 1, it means it's balanced. Your input is the same as your output. We don't want that with technology. We want our mechanical advantage to be greater than 1 so that what we put in multiplies. But in this case, I forced down 60 newtons, but I only got 15 newtons out. So my MA is 1 is to a quarter. So for every 4 newtons I push in here, I only get 1 newton of power out. So what's the point? Well, the point is we're getting a distance advantage. It's not coming out with as much force as you pushed it down with, but because it goes through a small nozzle, it also builds up pressure, but it gets more distance. What would be the point of spraying the deodorant that far? Wouldn't even get it near your little armpits. Right. So I hope that's helpful. The hydraulic jack. The hydraulic jack works on the same principles as the hydraulic press and Pascal's principle, where the input will be multiplied, providing a mechanical advantage so that your output can have a greater force, resulting in work done. Please notice that the hydraulic jack also has an input and an output. The input is operated by a lever arm, which pumps up and down, which draws in the fluid and pushes it through a small cylinder to a greater cylinder. And that will result in an advantage in the vertical lifting arm. I want you to write down the labels of each part of the hydraulic jack. You have a pump, which can be motor or hand operated. You have the reservoir, which contains the hydraulic fluid. You have the cylinder. And you have a one-way valve that prevents the fluid from leaking back every time you pump. Very important. The lifting arm will lift up the car. Then I'd like you to watch this video below on your own, which will tell you how the hydraulic jack operates. So, as we get towards the end of this lesson, I'd like you to keep a few things in mind. There's always a system. There's always a function. We have an input, we have a process, and we have an output. This is balanced unless the force is greater or unless the area of the cylinders differ. Right, that's the end of that. I'm going to be placing a worksheet on your tablet that I really need you to do. It's called Target Worksheet A. And I think we'll go through the answers in the following lesson. So, hope you're all doing well. Check out these links and best of luck for the rest of the week. Bye-bye.